Hello everyone, this is Mujahid Abbas, and in this session we will cover the topic structural isomerism. This topic is very important for A-level chemistry. Usually, structural isomerism is regarded as the base of organic chemistry. So, when you will start to learn the organic chemistry, so it is mandatory for you first to know about structural isomerism. When you talk about structural isomerisms, it is basically for those structures which have same molecular formula, their structural pattern and organization pattern. But what is the difference? Difference is in the arrangement of atoms. For example, we'll see a particular example here that is about propene. Propene having the molecular formula that is C3H6. So this is the molecular formula of propene. So this molecular formula can be written in two different structure. Like first of all, we may write it in this way. Like there are 3 carbons and 6 hydrogens. So you may arrange them like this way. First carbon, this is second carbon, and this is third carbon. And you have to arrange 6 hydrogen atom. So you may arrange them like this way, like this. There may be a double bond between these second and third carbon, and now arrange the with less like here is hydrogen on the left side is hydrogen on below side is also hydrogen, and the second carbon there would be only one hydrogen because it having the tetravalency, so it will make 3 bond with 2 carbon atom and one will make with hydrogen atom. And when you talk about this carbon, so it is already making 2 bond with this second carbon. So only 2 bonds are left. So it will make two single bond with two different hydrogen atoms. So this is the one structure we will get about the propene. But this propene having the molecular formula C3H6, it may be written in the form of, you can arrange 3 carbon like this way in triangular form like this. So there are 3 carbon atom. Okay. Now you have to place 2 hydrogen with this first one because it is already making 2 bond with 2 below carbon atom. So one would be here, other would be here, and same for this second carbon. It will make 2 bond with 2 carbon atom and two with 2 hydrogen atom. And similarly, this third carbon already making 2 bond with these 2 carbon atom, and two further it will make with 2 hydrogen atoms. So because carbon has tetravalency, so it will make 4 bonds at a time. You can notice here that each carbon is making 4 bonds, like two with two different carbon and two with 2 hydrogen atoms. So in this way, you can notice that this propene and this molecular formula can make two different structures. One, this is for propene and this is for cyclopropene. So this propene can be written in two different molecular formulas. One that is cyclopropene and the other one is only propene. So this propene is making two different structure, but you can notice here that having same same molecular formula, and also same organization pattern. But the difference is arrangement of atom. Where is the difference? Difference is in arrangement of atom. This is structural isomerism. So you can say that structural isomerism is a type of isomerism in which there is change in the arrangement of atom, but the molecular formula of the given compound remains same, but there is only change in structure or arrangement of atom. So structural isomerism has three basic types. One is functional isomerism, second one is positional isomerism, and third one is chain isomerism. So we'll cover each type one by one, starting from the functional isomerism. So starting from functional isomerism, basically, you know about functional groups. So functional isomerism refer to functional group. Between that, there is a same molecular formula, but there would be a change in functional group. Suppose we have a compound that is C2H6 and O. So this is the molecular formula of the compound, but this compound can make two different compound. But this compound can make two different structural compound based on their difference in the functional group. Suppose, first of all, it will make alcohol like this way. There are two carbon, six hydrogen, and one oxygen. So it will make like CH3, CH2, and OH. So this OH will make it alcohol. While on the other hand, this can be used to make ether like this way, CH3O, and again CH3. So you can note here, because of this will make it ether. So from here it is clear that having the molecular formula that is C2H6O. So here you can count there are two carbon, six hydrogen, and one oxygen, and there is resultant compound that is alcohol. While in this case there are two carbon, six hydrogen, and one oxygen, but here it is making two ether. So that's why in functional isomerism, because of change in functional group, like here there was OH that make alcohol, and here that was O that make ether. So because of the change in functional isomerism, so one compound can make two different structural compounds. So this is called functional isomerism. The second one is basically a position isomerism. So from name it is clear that that would be the change in position of a functional group or the different compound it carry or its substitute. Suppose if we have a compound having the molecular formula C3H7Cl. So this is organic compound having 3 carbon, 7 hydrogen, and 1 chlorine. So because of the change in position of the chlorine, so it will make different compound. Like this way, it will make like CH3, CH2, CH2, and Cl. So this is 1 chloropropane. 1 chloropropane. While it can be arranged in this way like CH3, CH, having Cl here, and here that would be CH3. So that may be called as 2-chloropropane. 2-chloropropane. So this is the way like having same molecular formula. So here this compound is making two different structures. So that's why we call it position isomerism, and that is because of the change in position of the chlorine. In the first case, chlorine was attached with the first carbon, while in the second case, chlorine is attached with the second carbon. So that's why because the change in the position of the chlorine, there is a change in the structure of the compound. So that's why we call it position isomerism. The third and last type of structural isomerism is the chain isomerism. So from name it's clear that this is because of the difference in the chain. Suppose if we have a compound having the formula C4H10. Suppose we have butane having the formula C4H10. So butane can be written in a straight chain or in branch chain like this way. Butane can be written in straight chain and also in branch chain. Straight chain, it can be written in the way like there would be 4 carbon atoms, so they can be written in this way. CH3, CH2, CH2, and CH3. And also butane can be written in branch chain. Branch chain. So in the branch chain, it can be written in the way like this is CH3, this is CH, this is CH3, this is CH3.